So I just wanted to quickly say thank you to all of you who are here. As you know, this is our community office hours event. This is our second event. We kicked this program off in January, so just last month. And last month we were on talking about networking trends we saw last year and what we were excited about in this coming year. This month we are talking about all things Kubernetes, as you could probably tell by the comic strip that was just up on the screen. My name is Katie Holmes. I run the ACE program and this community here at Aviatrix. We have Hamad Alam on. He is a VP of Networking Solutions, also at Aviatrix. And our guest speaker is Mitch Connors. He is our open source lead, again, here at Aviatrix. So the fun part about office hours is there are really no rules. We encourage everybody to take themselves off mute, chime in, ask questions. You can always ask questions in the chat as well. I will have a quick survey at the end where you can let us know if you are excited about any topics, you want us to feature any topics in future office hours. I already see a few familiar names on the screen here, so I'm happy to see some repeat offenders. So with that, I will put myself on mute because I don't think you guys want to hear me talking about Kubernetes. And so with that, Hamad, I'll hand it over to you. Thanks everybody again for joining.
All right, thanks, Katie. Welcome everyone. So let's get going. So the first thing I want to start with is everybody's welcome to have questions, and as Katie said, come off mute, put in the chat. But to get the show going, I had a couple of questions of my own that I wanted Mitch to answer. So before we get into that, Mitch, can you introduce yourself in the sense of why should we care about listening to you for Kubernetes? There has to be some backstory there, right?
I don't know if you should care about listening to me about Kubernetes, but I talk about it a lot and I enjoy doing it. I've been working actually on the Istio project now for a little over 5 years. I'm currently serving on the technical oversight committee and the steering committee for that project. So both technical leadership and then marketing guidance. That experience started at F5 Networks back in a long time ago, 2018, I think. And then I moved to Google, worked on Istio there, and now here at Aviatrix. So I've got a long history of experience in the cloud networking space, in helping customers tackle, the various problems associated with offering high performance services, migrating to the cloud, migrating to containers, and all of the implications of those technologies for networking. And my passion is helping customers to move forward without lift and shift, without re-architecting everything that they've ever done in order to fit whatever the next new paradigm is. I'm sure there'll be one after containerization and Kubernetes, there will be a new one. And finding ways to move forward without just reinventing the wheel is really my passion.
No, that's fantastic. So, joke aside, I've had the pleasure of working with you on multiple projects now, and I really admire and enjoy the insights that you bring, of course, the product insight, but also not just from a product perspective, but also from community perspective, that how, especially these open source projects thrive in the community and from the community. So to kick things, to get things started, right? Let me ask you this kind of open-ended question. So when I say the word Kubernetes to you, right? There are these words that may mean different things to different people. Like you say Paris, and somebody's going to think about fashion and Eiffel Tower. I'll probably think about croissant or Alex,
Yeah.
you can fix me or fix how do you say that? So when we say the word Kubernetes, what is it that comes to your mind? Like, what's the first thing you're thinking about?
Well, my answer is a little bit different than most. I think if you were to ask, like at KubeCon, if you were to just go around asking this, you would find most answers fall into 3 categories. I'm of the opinion that the best thing about Kubernetes and why we're still talking about it is its API paradigm. It's more than an API. There's all kinds of other stuff going on. But at a high level, Kubernetes gives us the ability to use a declarative API that has consistent shape for each object that you're going to interact with to specify what you'd like happening in your production infrastructure. So I can say, in Kubernetes with other software involved, I can say like, well, I want this application running globally. Maybe I'm using Karmata. So I give the application spec, I'll give a few networking rules, and then Kubernetes APIs take that spec and work on making it a reality. And they'll continue working. That might take hours or days to work on and get it scaled up. They'll just keep working and working and working until production state matches the spec. For my money, that is the most amazing thing about Kubernetes and why I love it. Oh, I think you might be
Yeah,
muted.
sorry. That's fantastic, because this concept of real desired state and realized state is pretty amazing. You said a word I want to double click on a couple of times. You said production infrastructure. So what are some of the common patterns you're seeing with Kubernetes, like adoption and continued adoption, especially now that, with cloud, we are seeing more wider and deeper adoption by the large enterprises. So what are some of the patterns that you are seeing in the industry and as you're talking to the customer?
Well, the first thing to keep in mind is that even though, you just showed a Dilbert cartoon from 2017, that's 7 years ago. Kubernetes was a big enough deal back then for Scott Adams to know about it. Even though that was 7 years ago, we're still early days for Kubernetes. If you look at enterprise Kubernetes adoption today, something like 1 in 3 large enterprises has some form of containerization running in production, but it's not going to be all of their containerization. If you actually look at enterprise apps, we're closer to about 5% of enterprise apps today run in containers. So there's still a long, long ways to go in terms of Kubernetes adoption. That being said, the trend that I'm seeing most of these companies that succeed with is one of platform engineering. Kubernetes and all of the associated technologies, be it service mesh or GitOps or various other tooling, it all becomes very complicated. And if every developer in your organization needs to know everything there is to know about troubleshooting Kubernetes in production, about getting Istio, Linkerd, or Cilium up and running, how does your CNI policy interact with your service mesh policy? It's overwhelming. There's too many skills that they would need to know. It'd be sort of like asking your engineer to first physically build the server, then physically rack the server, then provision the operating system on it, and then put the software on it to run. No one should have to have that much expertise. And frankly, if you find someone with that much expertise, their skill set is going to be quite expensive. So instead, what you want to do is get a core team of platform engineers who have deep expertise in these technologies, who deeply understand the service mesh that you've chosen to use if you're going that direction, or your CNI, your layer 3 networking abstractions on the networking side, maybe your firewall rules and intrusion protection and detection. Then on the orchestration side, someone who deeply understands how nodes are provisioned, how clusters get upgraded, how to keep a GitOps pipeline healthy, how to integrate with a telemetry store. These are all things that your engineers, your average software engineer in an enterprise, should not need to think about. They get the benefit of it. They get to write software, focus on what they're good at, their domain, and then reap all the benefits of having this platform underneath them. But they don't need to know how the platform works necessarily.
You said so many things, and there are so many questions I have in my head with that I want to hear your comment. But I want to take a pause and allow our great audience here to chime in and ask any questions, or just comment on what they just heard. Anyone?
Hello.
Hey, wow.
Hey.
I want to ask what time when the Kubernetes is not useful in solution, meaning when time we can use Kubernetes, one time when can be not needed to use, meaning depends on infrastructure, cost, performance, and those factors.
Okay, so when is Kubernetes not the right solution? Did I get that right?
Yes.
That's a
Okay.
fantastic question. I love it.
That is, and if you saw the comic strip earlier, we were showing the Dilbert Kubernetes comic strip, where of course pointy-haired boss wants to solve all of his problems with containerization in Kubernetes. This is a trend in tech. It will always be a trend in tech. that whatever the newest cool thing is, we expect it to solve every problem. And of course, it never actually does. In my experience, customers struggle to run Kubernetes or stateful applications like databases in Kubernetes. It's possible to do, and there are a few databases like Vitess that have been designed from the ground up for running on Kubernetes, and those have had some degree of success. But particularly taking like a monolithic SQL store, say a MySQL database, or an Oracle database, and trying to shove that into Kubernetes, or a Postgres database. Typically, I've not seen that be extraordinarily successful. You can get it to work, but all the effort you put in along the way, you're going to get to the end and ask yourself, wouldn't it have just been easier to spin it up in a VM? Like, I just spent months of engineering time getting this thing to be as good as a VM. And so there's not a huge advantage to sinking all that effort in my experience.
In case in multi-cloud, how to manage with the Kubernetes? In case in multi-cloud, meaning there's no vendor locks on those solutions, we make it as a layer for all of them.
Yes.
In that case, what's the solution? I mean, there will be security in that one and all of them. For example, if you use Aviatrix solution with the Kubernetes in multi-cloud, how can we do that, and how you can manage the networking infrastructure with that?
This is great. A great question. Yeah. So overall, for multi-cloud strategies in Kubernetes, Kubernetes was designed to enable multi-cloud. That was its whole purpose. The reason that Google, put it out in open source and got other companies behind it was effectively to enable companies to pick their cloud, not based on what APIs they exposed in terms of running an application, but rather on other characteristics. So theoretically, you should be able to take your Kubernetes app, you run it on EKS, you run it on AKS or GKE or Oracle or Rancher, and it runs the same. There's a few sharp edges there, and that's why largely if you're interested in a multi-cloud strategy, I would recommend that you not adopt features that are proprietary to one cloud or another. So for instance, GKE Autopilot is this awesome thing that if you're only on Google Cloud, it'll upgrade your nodes automatically for you without any downtime in the cluster. It does several other things for you that are really fantastic. The problem with that is that's not available in AKS or EKS. And so what ends up happening is you have to have different rules for running in different environments. So I would avoid those features as much as possible. In the case of Autopilot, I would get a regular discipline around how to upgrade Kubernetes clusters in a managed environment across all of the clouds that sort of fits all of them equally well, so that you're not bitten by, oh, well, we've migrated our application and now we have downtime because we didn't understand the differences between those environments. So that's kind of on the multi-cloud strategy. In terms of Aviatrix, we provide a layer 3 underlay for your Kubernetes clusters. So we've spoken with a lot of IT folks who said, or especially network engineers, I don't know what Kubernetes is, but a software developer came to me the other day and he told me he had to have a /14 network. That's 1/64 of the total addressable private space. And I've never had to provision anything like that before. I don't understand why he needed that much space. And also I asked him, what subnets are going to be there so that I know what's what. He said he doesn't know what's going to be what. There's only one subnet the whole thing runs in. Well, that's not an ideal interaction or experience. And so we try to provide tools to help network engineers sort of understand Kubernetes. We're working on incorporating a Kubernetes section into our ACE training as we speak. And then also to manage some of the heavier parts of Kubernetes. So for that /14 network that you need to provision a GKE cluster, we recommend using network address translation, NAT. Putting all the pods behind source NAT makes it so that you're not so worried about IP address exhaustion. In that model where you need /14s, if you need 64 clusters, you don't have any room left for any other addresses within private space. So putting those pods behind NAT, but keeping the services not behind NAT in an addressable subnet, we find is a pretty common solution. And of course, Aviatrix will provide those NAT features for you This is not intended to be like an advertising event for Aviatrix, so I won't dig much deeper on it than that. But Mohammed, if you'd like to dig deeper on that, please reach out to your solution engineer and have them pull me in. I'd be happy to get involved with you.
That's fantastic. Let me double click on what you just said about autopilot. What about the push from CSPs with Anthos and EKS Anywhere kind of strategies?
So that's a bit of a loaded question because I did work on Anthos Service Mesh in my time at Google. So that's something that I've contributed to. And I think, the product itself was fairly compelling, but there's a major problem, and that is that no one wants to trust a cloud provider for a multi-cloud solution. A cloud provider is not incentivized to make their multi-cloud solution work equally well on every cloud. They're incentivized to make it work well enough on everyone else's cloud, and especially well on their own, so that they can get a customer on the hook. They've migrated onto their platform, and then they can say, oh, well, if you really want the top price performance, you should just go ahead and migrate those workloads over to our infrastructure. And I don't think that was never explicit at Google. I'm not suggesting that, they dropped the don't be evil and picked up be evil as their motto. That's not what happened there. But I think from a customer perspective, it's hard to understand or to trust why a cloud provider would give you a great experience on someone else's infrastructure. I think that's true of Azure Stack and what the great folks at Microsoft have done. I think it's true of Anthos. And AWS has some similar offerings, although they're a little bit less aggressive about it because they're the dominant player in the cloud space, so that they don't need as much of a multi-cloud story.
Yeah, that's great. All right. Anyone else?
So, question from me without too much experience in Kubernetes. What about the different CNIs, right? So if you go to each and every cloud vendor, you're going to get a very different CNI. You're going to get a fairly different experience. Now, I'm not sure how much of that you can actually hide from your developers, but from let's say the networking perspective, it all ends up being very different. And if you have multiple clouds, then you need plenty different people to actually have specialists for each and every one of those. So what's the best way to address that kind of difference?
So CNIs, there's a lot of different CNIs that offer a lot of different features. However, most of the cloud providers seem to be standardizing on Cilium for a CNI. I know that both Amazon, it's not Cilium, it's a Amazon fork thing, but it's effectively Cilium. Google, it's explicitly Cilium with their Data Plane v2 project. I believe that's the case on AKS as well now. What I would look for there is there's certain features that are more or less common to all CNIs today. Think network policy. You can take a network policy from Calico to Cilium to, I don't remember, do people still do Flannel? And the network policy is going to more or less work consistently across those CNI implementations. If you're looking at more advanced features, I know that Cilium does some like telemetry sort of layer 7 inspection stuff with some hand waving there. Those are the sorts of things that I would get a little bit more cautious about because, again, you're not going to get that consistent experience. The other thing is all the cloud providers will allow you to bring your own CNI. So if you do want to leverage advanced CNI features, just pull out the cloud provider's CNI, install your own, and leverage the features there. There's also the question of service mesh. And that just depends on which layer you want to be able to author your policy at, whether it's CNI or service mesh. You did mention abstraction from developers, and I would say I have a very strong opinion on this topic. And it may not be shared by everyone. You'd probably get different advice elsewhere. I would not have your developers interact with CNI whatsoever. I would provide developers with a very limited interface about how to describe the networking needs of their application, probably identity-based, and then translate that into a network policy or a layer 7 authorization policy or a firewall rule, or maybe all of the above if you have like a defense in depth sort of scenario. I would not rely on them to author those things themselves.
Okay, thank you.
That's a fantastic point because one of the things that I've noticed is, especially in the cloud, the ownership of environments is very different. Where anything that runs in a VPC or a VNet is sort of assumed to be owned by the app team or the cloud team, right? And infrastructure teams have very little say of what goes inside a VPC in the application space, especially. So what's your experience in that enterprise world where the Kubernetes clusters and the apps that are running on it are actually owned by app teams? And now as an infrastructure person, you're coming in trying to say, no, your scope is just this much, and I'm gonna own everything that you run on, and I'm gonna define that. Like that I've seen that to be pretty a frictionful experience. So what's your experience on that?
This is the same experience that we all had a decade ago. If you were in the industry a decade ago, you may remember the cloud became a thing. And maybe like 2008, we all started looking at AWS, and developers migrated their applications to the cloud. And over time, those applications became more and more business critical until IT noticed and said, oh, wait a second, here's all these business critical applications, and we have no visibility, we have no control, no idea about cost, no idea about data security, any of it. It's just Wild West out there. And so the IT spent the next decade trying to sort of wrangle control there. And there were two ways that they approached that, the carrot and the stick. In my experience, looking at organizations, the stick mostly didn't work. Developers have options. So in companies where IT came out with the stick and said, you will submit to these new rules and install these new sort of oversight policy agents and things like that, or else developers said, okay, thank you. And then they went elsewhere and continued doing what they were doing before. The carrot option I saw being much, much better. For instance, they said, hey, developers, right now, you each own your account, including billing. We're going to be rolling out shared resources on a shared billing system. And based on that, we think your billing could save this much money a month. We're going to go ahead and tie that into the performance analysis process, our review process for engineers. Our promotions will be based on resource savings. There's a great carrot for us to go ahead and move on to these systems. I think the same thing is necessary for Kubernetes. You don't want to come in and say, hey, you've had all this freedom. Well, now we're taking over. What you want to do is do it better. Say, hey, look, I know that you guys have had trouble. Look at Log4j. You guys had trouble patching that. Maybe it took some of your teams 4 months to get it patched across all of their services. It was this big scramble, people working weekends and nights. No developers like that. If you move on to our platform, maybe we have a network security policy using Aviatrix or a service mesh that could have just blocked the Log4j exploit at the front end and simply not allowed those sorts of requests through to the backend services. Granted, you still need to patch the software. It's not a long-term fix, but think about that as a developer. Now you're being told, remember all those nights and weekends you worked? You won't have to do that if you move on to our platform. There's the carrot for people to move on to an internal developer platform.
Fantastic. Fantastic. Somebody talking from experience. Loved it. Thanks for sharing that. Anybody else want to chime in? Any further questions? So I'll double click on something you just mentioned, which is, I think, very interesting.
Hold on, we have someone in the chat. Mohammed has asked, how do observability and monitoring with Kubernetes to be extended at multi-cloud as a single pane of glass? Ooh,
that was exactly the question I was going to ask. So let me double click.
I got to tell you, they might be better at asking these questions than you are. I'm sorry. You're doing a good job here.
Awesome.
So yeah, let's talk about that. There are some packaged solutions that you can get for observability and monitoring in Kubernetes. But in my experience, if you're at a sufficiently large enterprise, you probably already have infrastructure around monitoring. And the best thing you can do for Kubernetes is integrate all of your platform telemetry and observability data with whatever your enterprise is using today for monitoring their production site. And the reason for this, I learned at Google. I wanted to run an application on Istio at Google. Istio, of course, is an open source project launched by Google, but not used internally at Google. It's inspired by software that runs internally at Google, but it's just an inspiration. It's not API compatibility or anything else. And so I wanted to get production experience with Istio and run something simple, right? Our menu app that tells you what's for lunch on Istio. And the roadblock that I hit every time that I tried to do this was SRE, Site Reliability Engineers. Every app at Google runs with an SRE team, and they simply will not allow you to move to production on an app that does not integrate with their internal telemetry tools. And at first I thought this was ridiculous. This is the stick, right? Everybody must do this or else. And I didn't really understand until I sat with an SRE for a day. This SRE owned, I think, about 15 different applications in production. And when a page goes off, he goes to a page that looks exactly the same for every application he owns. It shows exactly the same 5 golden signals for every application so that he can immediately begin digging in. The first 5 layers of digging in are the same for every application across all of Google. Completely consistent, so that an SRE doesn't need to have deep knowledge of the particular application he's debugging. Oh, for this one, I need to go look at Grafana, and for that one, I need to go look at AWS's telemetry console, and for the other one, maybe I need to go look at ServiceNow tickets. It's all in one user interface for the entire enterprise. So which one is the right one to adopt? Mohammed, I would probably say it's the one that you've already got adopted. Find a way to bring Kubernetes into what your company is already doing today.
Let me double click on that. So what you mentioned is absolutely great, but that's from the app layer perspective, like native Kubernetes, what is showing my performance, app performance and stuff. How do you marry that visibility, or from an SRE perspective, to the network? Because the Kubernetes space shows you what's going on inside the cluster, but everything lives outside the cluster. So how do you connect the two dots and actually do an end-to-end troubleshooting?
The problem's even bigger than that, because if you go back and read the Kubernetes white paper back from, what was it, like 2014, a bunch of guys in Seattle at Google published a white paper about what Kubernetes was meant to be. And they talked all about orchestration, declarative APIs, containers. And then there's one paragraph that says, we're going to need to ship some basic networking features, but somebody really ought to spin up something else to figure out networking for this thing. Because it's really just, we're going to give really fundamental features and we don't think they're going to be enough. Our focus, it's valuable for a project to say, here's what we're about. And what Kubernetes was about and is today about is orchestration. How do you get your software to run where you want it, when you want it, reliably? The networking problem was a secondary problem, and that's why the service mesh space exists today. Service mesh has taken advantage of Kubernetes orchestration and said, what if we could put effectively a small Linux box in between every single server and the network? You could, in doing that, you capture all traffic, you get to see everything, and you get to apply all kinds of rules for it. Well, that's awesome. And it's had a lot of advantages. It's had huge adoption over the last, say, 8 years. But the problem with it is it relies on Kubernetes orchestration. It relies on the ability to place that box or that agent at every single computer. So if you have today an existing network based on layer 3 policies, firewall, VPC, subnet, etc., Kubernetes is going to use one subnet across all of its pods. So if you have 1,000 apps in one cluster, you have one subnet that has 1,000 different apps in it. And it's really difficult to see from the layer 3 perspective what's going on. Even if you happen to get a list of IP addresses and say, okay, these IP addresses are for that service, these are for the other, in a minute they'll change. As soon as a new deployment spins up, something changes about the code, all of those IP addresses for that app are going to shift. And then you've got to update your layer 3 policies to reflect that. So it's very difficult from a layer 3 perspective to manage Kubernetes. And it's very difficult from a service mesh perspective to manage VMs where you can't schedule that agent. It's a high friction experience. what platform engineering teams are doing today, and what I think you're going to see products moving into this space in the future, is developing solutions that reconcile those two ideas, that make it so that you can have one definition of policy that applies whether you're inside of Kubernetes or outside of Kubernetes. That's certainly where we're iterating towards as Aviatrix. We're going to have some announcements in the coming month to that end. But we've also seen, since there's not much in that space today, we've seen platform engineering teams tackling that problem themselves at successful companies.
So you've mentioned this term a couple of times today. Everybody's familiar with SRE, right? But you mentioned platform engineering. Do you want to enlighten us a little bit on, is that a new wave of job titles that we should be looking out for?
We mentioned earlier that like all the old things are new again, right? This is a very cyclical industry. And so platform engineering is the next generation of infrastructure as code, right? IAC was this big deal, I don't know, 8 years ago. Everyone started putting all of their definitions of what infrastructure they needed to run their app in production in code and storing it in Git. It was great. Use Terraform typically, or Ansible or things like that to sort of provision infrastructure. It was a really cool idea. There were a couple of hangups with it. Probably the biggest one was that the experience was tailored around the command line experience. So you set up your Terraform file and you run Terraform apply, and that's great. And now all of a sudden all that infrastructure is out there, but 2 hours later, something's changed about your infrastructure. Something else got deleted, something else got created, because people still have access to the cloud console. And what's going to happen is the next time you run Terraform apply, it's going to correct all of those changes. But in the meantime, in between those 2 runs of apply, who knows what can happen over time. So that's called configuration drift. And what we've discovered is it's really not ideal to have your experience tailored around the command line. Instead, you want your experience tailored around the API, which has largely become, for infrastructure as code, has become Git. So in platform engineering, you don't typically run Terraform applies. If there is Terraform in your infrastructure, it's going to be run automatically on every commit. And then it's going to be run periodically anytime that it detects that configuration drifts. Next generation tools like Argo CD don't even have periodic runs. They will actively listen to your production environment for infrastructure and correct as soon as there is drift, rather than waiting for those periodic runs or polling. To me, that's the big difference between IAC and platform engineering. It's just slightly more mature, slightly newer idea, but very much the same principles.
Awesome. So as we're 30 minutes in, so I'm gonna start to try to wrap it up and give some time back for everybody. So if you have any questions, please feel free to chime in the chat. We have 2 questions waiting, Mitch. So the first question is, I would summarize that as active, standby. So one of the things that you just mentioned, people have massive clusters, right? So if I have a cluster in a subnet, how do you build resiliency for it, essentially, whether in single cloud or in multi-cloud?
This very much depends on your scale. At low scale, active standby is viable. You need to have some sort of checks to make sure that your standby is ready to become active. Possibly this looks like regular swaps from active to standby, flipping over maybe on a weekly basis or something like that for your team to make sure that both environments are production ready at all times. But, let's say you're only spending a couple $1,000s a month on your production cluster. You can afford a couple $1,000s a month on a standby cluster that goes idle for most enterprises. That's not going to be a deal breaker. However, as you scale up, if you're spending $100,000 or a couple $1 million a month on infrastructure for your cluster, all of a sudden your standby, you really need to shrink it. You need it to be much smaller, which then means when you have an active to standby or a standby to active swap, the cluster has to dynamically scale up during that event, which means it relies on infrastructure being available to scale up. We've seen with the chip limitations in the market that some of the cloud providers have occasionally been running out of infrastructure, and those scaling events have not happened. So it gets to be more and more difficult to manage, more and more money on infrastructure that is not really operating at full capacity. And that's where enterprises typically make the switch to active. Active takes more investment from a software engineering standpoint or an infrastructure, maybe a platform engineering standpoint, because you've got to be able to manage that traffic gets between both active pairs. It gets balanced in some way. Some traffic will need to go east-west between them, but you really don't want traffic to go completely between them willy-nilly, because typically that multi-region link is going to be expensive in terms of bandwidth. So you're going to need some concept of locality-aware load balancing going on. There's investment that has to be done up front to make an active work, but the advantage is you can run your infrastructure at, say, 80% utilization at all times, rather than down at like 40% utilization in case of active standby.
Great response. The second question, it's a long question. You can read on the chat if you want.
Yeah, let's see. Ooh, a gateway deployed in Kubernetes. This is a topic near and dear to my heart. So we do have gateways deployed in Kubernetes internally in our lab. Not something we've made available to customers yet, but we are playing with it and trying to understand the advantages. I think today, because all of our traffic capture is based on BGP, there's not a compelling reason to place the gateway inside the cluster. I can't get too far into blowing the whistle on a press release that is coming out in a couple of weeks. Suffice it to say that we do have a way, or we are going to have a way in the very near future, of writing policy that applies to Kubernetes services, not just to an entire cluster, but it will not require running anything inside a cluster. We don't feel we could run it in a cluster. It simply doesn't seem to be necessary for the solution that we have in mind. In the future, if we decide to go a direction similar to CNI or service mesh, it may eventually become valuable to have something in the cluster. But our analysis is very much around cost benefit. If you already have gateways running as VMs today, capturing traffic via BGP, there's no real reason to run in the cluster. We can't find a compelling reason for that today. Like I said, tomorrow, whole other story.
Thanks for sharing that. And last question before we wrap up. For security in Kubernetes, what are some of these strategies at high level that you would recommend for people to follow?
I recommend to follow a lockdown principle in Kubernetes, which is to say your default platform perspective should be that developers get very little privileges. For instance, developers should not be able to log into production, probably under any circumstances. Maybe there's a break glass option in case of a serious outage, but that should never be necessary. You should have sufficient telemetry and log production pipelines that you really don't need to log into production. You should have a default network policy, whether it's a CNI network policy or a service mesh network policy or a firewall that applies to all applications and is default deny. So unless you've explicitly requested traffic, you don't get that particular traffic. Now, that's really hard to do in case of brownfield applications where you're migrating something, there's already a lot of traffic going on. So in that case, Aviatrix or other solutions can provide telemetry on what traffic exists in your mesh, so to speak. You're not necessarily using a service mesh, but your services form a mesh with all of that east-west traffic. You can watch that traffic, and then you can craft the policy based on what you see. There's even some tools out there in open source that will help you to do this. But what you want to do is you want to iterate to the point where you can write a default deny policy where the only traffic that flows in your network is traffic that has been explicitly allowed. And that would be, that's the policy that I would look for, and understand that you can't just turn it on in one day. You've got to iterate towards that and do the groundwork.
Thanks, Mitch. Really appreciate all the wisdom that you shared and the experience. I love the conversation. Thanks everybody who joined for the great questions. With this, I'll turn it over to Katie to wrap us up, and thanks from my side.
Thanks, Hamad.
Thank you, Hamad, and thank you, Mitch. And thank you, everybody, for joining. Loving the claps, Roy. So next month, we will be on talking about career advancement in the cloud. So I hope that you guys found this session insightful and useful, and I hope you join us again in the future. I did share a survey in the chat. We'd love to hear from you, hear what you guys thought about this event. Obviously, this is a brand new program, so we are totally working to improve and grow alongside all of you. Also an opportunity to request some topics for future office hours. So we'd love to hear from you, and thank you again for joining. Bye-bye.